So, as I heard also yesterday, some of you are going to write plugins. Some of you are going to write mostly workflows. Some of you are going to actually look to support different a new code. All of that is shared. Like if you want to really share that with other people, you will actually write a plugin. So, let's look at what plugins can do. First of all, yes, it's an easy way to share workflows. Support new, also support different supercomputing infrastructures with different schedulers and whatnot. That's not supported yet. You can add support for that and ship that to anyone, basically. And you can support new data formats. Someone is going to actually probably support something for force fields and so on, for I think MD codes. And many more things. So anything that extends AiiDA and doesn't actually change internally the way AiiDA works can be done as a plugin. So yeah, it really doesn't work. Now this is not the current, but the future, very near future way of installing a plugin. And this is it's important because it changed recently, and it's for everyone who's only going to start writing a plugin. It's going to be quite nice. Everyone else, for them, it's also going to become quite nice. So what you will have to do is install a Python package, which is AiiDA core, which before you just downloaded the AiiDA source code and did some manual path adjustments, and it will work. And in the future, you will just be able to download it, use the usual way you install Python packages, install it, and then once you've done that, you can download and install any plugin, and it will just work together. You won't have to do any. You won't have to touch the AiiDA source code, which was the old way. So this is going to be. This is already implemented, and it's not shipped in a version yet, but it's going to be one of the following versions. Oh, so before. I'm sorry. So before I show you this in action, I wanted to cover some of how it works, because that will make your life easier. Knowing that will make your life easier when you actually implement a plugin. So we start with the Python ecosystem, and I think most of you probably have installed the Python package before, and most of you probably have used NumPy. I don't know, maybe PyMagen, ASE, anything like that. So typically the way you do that is you run pip install NumPy, in this case. And pip is this program here that you have in your Python installation. It uses this Python package in the background. And it communicates with the PyPy, the Python package index, which is like a cloud service hosting Python packages. You will be able to host your plugins there, and people will actually be able to just pip install your plugin, and it will work. The plan is also to host AiiDA up there, which is not currently done, but it will be. So now let's look what happens and why this is actually really good for installing AiiDA and plugins as well. Because what pip does is quite clever. It downloads the package, looks at what the package defines as dependencies. In this case, we just call them ABC. Then it actually downloads the dependencies and installs all of that into your Python installation, into your library. And there we go, successful. We have NumPy now. It works. There are two ways mainly to do such an install. They are subtly different, and for everyone who's going to develop a plugin, this is really important to know. And a lot of problems I've seen on mailing lists and so on arise from not knowing this, so I want to cover it. You can just run pip install the distribution. This is a distribution is also often called package. It's basically the package and something around it that tells pip what and how to install it. For example, the dependencies we saw, they are defined in this setup.py file, and together with the package, I will call it distribution to differentiate between the two. So what pip install this distribution. The name of the distribution and package don't have to be the same, by the way. In the case of NumPy, it's the case, but it doesn't have to be. So when you call pip install distribution, it will look at the distribution, set up the py. This will tell it that the package is there and some other information. And it will copy the package into your library folder. This is pretty much what it looks like on your computer. And it will install a separate directory with meta information, like dependencies and the version of the dependencies and other things, and some of the other things we actually use to make that magical. You just install both packages and they work together. We make that work through this. So there is another way, which is very useful for developers. That's why I'm mentioning it. You call pip install -e distribution, where E stands for editable. So what this does is it actually just installs a link into your library, and the meta information and the code stay into in the folder of your distribution. So this assumes that you have downloaded the source code somewhere and install it with -e. And that means now, if you change any of the coding here inside this package, those changes will automatically be reflected. So that means while you are writing your plugin, I would very much recommend installing it this way. And as you write the plugin, the changes will be used automatically by AiiDA, by Python in general. So even if you've never done anything and are going to start writing a plugin in a bit, this is, you don't have to remember this by heart. We will give you the slides if you like. But you can look it up here, and it will be very helpful, I promise. So this is just an overview of how AiiDA will be distributed. So it's going to be a package or distribution, if you like. Right now, it's on GitHub. You can download the source code, pip install it, and you can do the same with plugins. Wasp, this is going to be maintained by me. CP2K, I know, is already quite up to date with this, I think. And yeah, also all the plugins which are now inside AiiDA will be distributed this way. And because we don't enforce those packages to be on PyPy, they can be on GitHub, Bitbucket, whatever you have. They can be distributed via email. We will have a central registry where all the plugins that we know and that have been tested and which you can trust will be hosted. Well, no, they won't be hosted there, but information about them will be hosted. Also, how we will get it. So this should be accessible by some command line command, like Verdi plugins, let's say search. And you get a list of plugins that you can easily install. And for each plugin, you can look up how to get it. Which brings us to environments, because when we actually install something, as Python developers, we call that we install it into a certain environment, which by default, if you use pip install, it will install it into your base environment, basically. That's why you have to use sudo on some machines to install. Can be avoided by giving it, specifying that you want to install into the user environment, which would be somewhere the user local. The other one is the user lib. It's not very important to know these, but it is important to know that that where Python looks for the Python executable and libraries can be given by those bash variables or shell variables. And it quite depends on which one of those folders is first, as to like which library you get when you import it. So you can actually install the same library in multiple of those environments, and it might not be clear which one you actually get when you request it. And that's important. It's an important point, because there can be clashes. You can actually inadvertently mess up your environment And this can happen like something like this. Let's assume you install NumPy and it has a certain dependency, like let's say package A in version 2. And then you want to install some package that a colleague of you wrote, and you really have to use it, but it relies on having specifically this package A, but in a much older version, which wouldn't suffice for NumPy to work. If you now just install it without thinking about the environment, you will actually install all the dependencies, including this old version, as you can see here. And now, NumPy stops working. It's just an example. NumPy is pretty robust, but other things like, well, typically production code, you don't want to rely on this not happening. And that's why quite a while ago, people came up with the idea of virtual environments, which are basically this box represents your bin and lib and according path settings. So you can, with a command, activate this environment. It will set your paths. You don't have to think about it. But if you use Python or install libraries or anything, all will happen in this environment. That means everything else is left untouched. So you can work on your private projects and install something else in a separate environment, and it will just run.
How it solves the problem? So if you have in your local environment, you need to have two packages, NumPy and your local stuff, and they still collision. How it solves it?
Okay, this is how we solve it. We install NumPy into the currently active environment, in this case. And then we want to install, this local package or other package. And keep in mind, we can never work with them both at the same time. What we could do is we could install one, work with it, then reinstall the other, work with that, but they will never go together because this kills this. So whatever you do, you are going to have to do something in between. But instead of manually keeping track of everything that this overwrites, you can just activate a different environment. Oh, here we go. Basically, taking this out of the path, so Python doesn't even know where this is for the moment, but it knows how to find this. So if you install the other package now, it goes into here, and they are isolated. OK. The next point to keep in mind, to know how actually the AiiDA will find plugins that you distribute in separate packages is something called entry points. As I said, it's just a piece of meta information that you give in the set.py. And when you install it, it will go to the right place, and AiiDA will just know that your plugin, that your plugin provides this specific class. It's a mechanism implemented in the setup tools library that we mentioned before that pip relies on. And what the plugin has to do is give the following meta information just a group name, so that, for example, AiiDA workflows. You say, I have for the workflows, I give this certain class with the name this. So AiiDA will just find this name and will be able to load this class. AiiDA will be even able to iterate through all entry points in the group, let's say, workflows, and find all workflows defined by all plugins. And the user then can just choose which one to load. And this is actually done in a way that's exactly, like for the user, it's exactly as it is now. So you use the class factories, you use, if you use the same factories, everything works transparently. And now I'm going to show, hopefully, this whole system in action. So if you want to follow this now or later, it's all the scripts that I'm using, which basically have the commands that I will show, are on this GitHub repository. And I assume that you can just...
Give it a shot.
Yeah. get me into the shell. Oh, very good, yeah.
Perfect. You want to duplicate it?
I would prefer, yeah, I would prefer that. Yes, very good. Good. So, thank you. Okay. First we have to go, here we go. All right. So the first, the demonstration is grouped into chapters. The first chapter will just demonstrate how to use virtual environments and how a clash, we will try to reproduce a clash, which wouldn't usually happen, but it's easy to show this way. So, all right, we are ready. So, first of all, to use virtual environments, you have to install the virtual env package. In this case, it's already installed, so it won't download it and everything. But I think you know, all of you have seen that before, so we don't have to show it. And then you use the virtual env command provided by it to create a virtual environment, in this case called A. And you can have as many as you want. We can make one called B. And if we then run ls, you see it created actually two folders, A and B. Within those is going to be contained everything that you install and all the binaries that you install and use and everything. So now, as you can see, there's the bin, the lib, all of that. Now if you want to actually use one of those, we have to activate it. And I would agree if someone said that having to find this activate file for each environment can be a bit tedious. But there are programs that actually help you manage environments where you don't really have to do that. This can be abstracted away. You can also alias this, and there are many ways to deal with that. So in the end, it's one simple command that you run, and you're set to go. In here, we can, for example, install iPython. I think everyone would agree that iPython is a very useful library to have indeed. And once that it's installed, we can run it. Like, seems to work. It checks the version, everything all right. But if we install some other packages, which if you didn't pay a lot of attention to what happened above, you wouldn't even know necessarily that this might break something. Now running iPython just crashes. Simply because we installed this one package, which is a too old version. So in order to avoid this happening to you with your AiiDA installation, or AiiDA overwriting packages from something else that you want to use, we very much recommend using virtual environments, especially when you actually develop a plugin.
You should not have understood it when we were installing something old or broad. I mean,
I'm sorry?
You should not have understood that we break it. I mean, you install AiPython and you need another package than what you had, right? Or,
yes. So we install iPython. It relies on this 6 package in version 2.0 or something like that.
you had an older one.
And now we installed 0.9,
Okay.
as you can see.
Afterwards.
After installing iPython, iPython was running. We installed this old package.
I thought it was like
No, it was not the other way around, yeah. And we didn't touch iPython as such, but it now stops working. This can happen with anything. So we really recommend using virtual environments, and this is also reflected in the documentation for this version of AiiDA, where this is implemented. So what we can do is reinstall iPython. It will work, but now the other package has gone away again. So what we can do instead is activate our B environment. And by the way, if you paid attention, you might have noticed the active environment is usually displayed in parentheses in front of your bash prompt. Most managers keep this behavior. So it's always easy to know in which environment that you are. Now we can install our other package in here, and they are isolated. So if you want to actually check, you can activate this environment again and run iPython, and it works.
This is fine, but imagine you have in the future you're going to have the core AiiDA and then a multiplicity of plugins and workflows.
Yes.
You need to make sure that everybody uses the same packages, right?
We have to make certain that packages don't interfere with AiiDA's dependencies, yes. However, I think this is going to be really easy because every plugin writer will naturally, as they go along, test their plugin with AiiDA. And as soon as they interfere with the packages, they will notice. So
it's a problem of multiple checks. I don't know if the vast plugin developer is using some experimental package that's going to clash with mine if I'm using a stable version.
With okay, different separate plugins. That is true. However, there is a useful tool which is called pipcheck. So you can actually, as you develop, you can check for all the plugins that you have whether you break any of their dependencies. Yes, very helpful. Very much recommended.
I mean, if I take two plugins which use different version in their dependencies,
yes,
you can still break something by trying to install both.
It is true. And this will probably lead to us having in the registry something like this plugin is incompatible with this one, so you at least get warned before you install it. But in general, we will be looking to provide something like a rudimentary test where we install plugins, different combinations of plugins in like a Docker image, and you can take this, install your plugin on top of it, and check if it destroys, if it breaks anything else. We will try to make it easy for plugin developers to not break other plugins. And this is also made much easier by this architecture of having separate packages. The same actually applied to the previous system, where you just installed your plugins into AiiDA, and then you would change the dependencies of AiiDA if you needed anything additional to it. The same thing happens when you try to install separate plugins. So what's new is that this is still the case. You can still have plugin dependency clashes, but it's now much easier to check for them. So yeah.
What kind of plugin, what kind of packages do you need to write a plugin? Wouldn't it be better just to say to write plugins use only these packages? And
yes, there will of course be guidelines. The main thing is that we would say sometimes it might be the correct way to do it just to have a plugin that only defines a set of dependencies that then other plugins can depend on, so that everyone depends on the same versions. This is not very well. I mean, we have been thinking about this, but we are still implementing some of the things, so it's a bit in flux, and ideas are always welcome, of course, how to deal with this.
Just a typical case in which a problem like this could happen is if, for instance, two different plugins use a library to parse XML, let's say, but for some reason one of the two wants a specific version and the other wants another one. I mean, ideally, one should try to be as loose as possible, but I mean, again, if you are suggesting, we're very happy, and you are now in the problem. This is something we are starting now, so we see these problems. The advantage of having a registry is that we keep track in this registry, just name, URL, and version of the packages you are going to provide. This is mainly to have a unique string in the database, so we can say if you have a node which is identified by this string is, I don't know, the Blast plugin rather than the Siesta plugin. But this allows us also to have a kind of central hub where we know all the plugins which exist, and we can do potentially even automate. In the next talk, we'll show a bit how to automate some tests. We could even make some automated tests to check dependencies, for instance, and warn, let's say, developers saying, look, you're trying to use this dependency, but this clashes with this other person.
Yes. The problem really only arises if you specify, if one plugin specifies a specific version of a dependency. If two plugins use the same dependency and they don't specify one version, then they're not going to clash. They're just both going to use whichever version is around. So I think in most cases, it won't be a problem. In very rare cases, it might be, and then we will see how to deal with it. So if there are no more questions to just this virtual environment and dependency clashes, then we will continue with the next chapter, which is going to be actually to see how we can install a plugin and it just works. So we create a new virtual environment separately for AiiDA. We call it AiiDA. It's a descriptive enough name, I would say. We activate it. Yes, and then we clone the current AiiDA core. By cloning, I mean using Git to check out the current state of the repository. Change into it, check out the feature plugins branch, which is going to be mostly interesting for plugin developers, because this will be what you can use to check your plugins, to test your plugins easily. Successfully switch to the branch, and then we use this pip install -e. This whole line you will find in the documentation. You will find some explanations for all of it, basically. If you have specific questions to this, to how it looks, we can also talk about it right now. I think we have still a bit of time. Okay. So, yes. Since AiiDA has a lot of dependencies, this might take a while. I hope the internet connection didn't just crash. But in case it did, I have another, I have a pre-prepared environment where it's already installed. I hope we will be able to use the live version. Just a quick mention, this usually doesn't take as long. If you have a good internet connection, it's much faster than this. It's not that AiiDA has become much slower to install. It's just this is an Amazon machine, and sometimes if there are a lot of people accessing it, it slows down a little bit. Any questions up to here? Yes.
So I think it's already obvious to some people, but so this is about switching Python environments, but actually sometimes you would also like to switch AiiDA instances, right?
Yes.
That's not yet do that for you, right? Because it would still access to the same database.
It will, yes. At the moment, it will still access to the same configuration and database.
Is there an easy way to do that?
To
a convenient way, or how would you do that?
To separate, well, you can set up a different profile for a different version of AiiDA, for a different instance, but you have to make sure yourself that you only use this profile with this instance and not with the other one. We have been thinking a lot about this, and we think going forward we will support having multiple configurations for multiple versions of AiiDA, which cannot write into each other's database or anything. But right now, it's not implemented yet. But it's definitely something we will try to support.
You can use symbolic links for the database.
Okay.
And so it works for two versions.
Okay.
I'm not sure if it's robust enough.
You can use multiple versions with the same, yeah.
So even with profiles, you can use, you just remember profile A.
Yes.
So profile in AiiDA, for those who don't know, it's just a set of databases.
Yes.
That you need somebody to use one environment.
Oh.
Yeah. As Rico was saying, what we are going to do is to make sure that we also say this, as soon as this is merged, we'll have this feature where we say profile A always run with this version, and profile 2 runs with a different version.
Actually, we might have time after those demonstrations to look at it. But there is a way you can automatically activate an environment, and while doing that, change your symbolic link to point to a different AiiDA configuration and database directory. So this, when you call source environment bin activate, you can actually write into this activate script. It's just a bash script. Whatever you append at the end will be executed as well. So you can actually delete the link and make a new link to point to something else. So you can manually support that already. Okay. It seems that the MS1 machine has actually finished this. So we have installed the current version of AiiDA, this feature plugins branch. We cd back to our root directory. And now we run vertical calculation plugins, which those of you who've used it before. This command simply outputs the names of all the calculation plugins, or input plugins, as some people call them, which are currently installed. So, as we see, all of those, to people who haven't used it much, all of those are pre-installed. So there is no external plugin that has been installed yet.
And you will not separate those?
They will be, there are plans to separate most of them, specifically Quantum Espresso and WChem, I think, and COTools probably as well. The template replacer is so simple it might actually stay inside. Okay, so what have we done now? We have cloned this AiiDA mul. I call it mul because it multiplies two numbers. It's kind of a similar example to what we saw before. It's a sample plugin which I just made for demonstrations like this and for people to clone the repository, play around with it. We can pip install this. Since it doesn't have dependencies other than AiiDA, it should be fast, and it is. And if we run vertical calculation plugins again, we see in the middle this mul. So we didn't touch any of the AiiDA code. We just simply pip install our new plugin, and it gets recognized. Any questions about that? Okay. I hope this, yes?
How do you import your package now?
Import? Okay. If I want to run a multiplication, it's best to show this in the shell itself. The Vertishell preloads some of AiiDA's functionality, and I can just use the calculation factory if I'm not mistaken. And this,
You're not in the virtual environment.
Yes, and now we see that it's important. No, it's, yes. Now we just saw what happens when we're not in the right environment and try to call something that's in a different environment. So once we activate this, we use Vertishell and run the same command again. We see that we get back this calculation class, and we can just use it exactly the same way as we would have used it before.
But you notice it's not inside AiiDA this time.
Yes, this time it is not.
So you can also go from AiiDA more calcs and
Yes, if you know the name of the plugin, you can from this, and then as you see, this sub-package has this calculation here. So what you can also see right here is that AiiDA mul doesn't follow the same structure as AiiDA. It doesn't have an ORM, .calcs, whatever. But instead, the plugin developer is very free in what they want to do. In fact, this plugin also provides a parser. And I think the parser factory I still have to load, right? Okay, we'll just load it the easy way. Oh. Okay. Provides a parser as well, and as you can see, it's in a different module, in a different subclass. But in theory, they could be in the same Python file. So a plugin can be very simple. It can be a calculation and a parser all in the same file. You don't really, I wouldn't recommend doing that because it's kind of neat to have them separated. This is just to show how free you are. So you can structure your calculations, parsers, everything, workflows, what have you, in whichever way you want, as long as you tell AiiDA where to find it. And I would say you're probably interested in how to do that. So we will look at the setup.py file. And we'll get disappointed because all it does is load a JSON file and load information from there. This is done because this small sample plugin is actually in a registry, and the registry gets its information of how the plugin gets installed, all the dependencies and so on from a JSON file. And if you prefer to have this JSON file and the setup.py always up to date with each other, it makes sense to just read from the JSON file. It's very simply called setup.json. We will support also the YAML file format for people who are not so much a fan of JSON. But for now, I did it like this because it's a very good fit to Python's dictionaries. So in a setup.py, if you didn't use the JSON, this would simply be the keyword arguments to the setup function. So the magic, or since someone once said every magic well enough explained is indistinguishable from technology, the technology we use here is this entry points, which setup tools will see and will write those names and pass to an actual calculation, to the actual calculation like here. It will write that in a file, and AiiDA can then find it. Keep in mind that in order to find this, AiiDA doesn't have to import anything. It doesn't have to load anything. So there is no speed hit for searching through all the plugins available. You don't have to load them. You only have to look into those text files. Not you, but the backend does it. And just loop through all the ones which are in this group. And then you can load the ones that you want. You don't have to pollute your namespaces. This very simply is all the magic there is. Actually, we might want to add some of our own. And a very simple way to do this is to add a new entry point, pointing to the same class but with a different name. Let's call it mol2. Very inventive, I admit. OK. Since we now have changed some meta information, and as we know, pip installs the meta information separately, we will have to reinstall it. But it's fast. And we can run, maybe it's easier if I just, we can rerun this again, and we see it gets recognized immediately. Same works again with the factory, everything like that. Yes. The last, if there are no questions about this, then I have one last demonstration.
Can I just say one thing, just
Yes.
to clarify? So the idea is that, especially for those who already wrote a plugin, you just have to take what you have. You don't have to change much. You have just basically take his template, copy it, and create a JSON file. Where you basically say, I want this plugin to be called like this. Just copy the syntax, you change, copy and paste and change.
Yes.
And then you contact us just so we can add you to the registry. So it's assigned to you a given name. And that's it. I mean, just a bit of moving some files and adding a couple of files we give a template for.
Yes, that is true. If you have a plugin which you, chances are you already have a repository where you have all your files before you copy them into AiiDA. And you can leave that as it is. You just have this, you just point to the right place. You don't have to change any of your Python code.
It works with AiiDA 0.8?
With AiiDA 0.8, it should
probably
not yet work.
That's something we want to just also useful, something we want to release next week, probably what we have up to now. This will be in 0.9, but ideally we want to do it in 1 month. I mean, as soon as possible, compatible with the 2.9. But it's already in a branch Rico showed.
Yes.
So if you want to play with it, that branch is always kept up to date with the most recent AiiDA.
Exactly. So once AiiDA updates to 0.8, all those changes will be in that branch as well. Okay, in that case, we can go on to show a bit of the registry, how it works. We don't have to see, we just have to do this. So we again activate the AiiDA and just to make sure that we can run the proper Verdi command. And the commands that I mentioned before that look up in the registry which plugins are there and so on, they're right now in a separate GitHub repository, yes, which is also a plugin, so you can just install it next to AiiDA and it will provide this Verdi plugin, a Verdi plugin command. The Verdi plug will be the main command line entry point for those experimental commands. So we can just search with no arguments, and it will just give us a list of all plugins. Right now, there is an experimental Quantum Espresso plugin that's separated from the core, and this plugin to play with. We can already, so for everyone who is developing a plugin already, we can start right now. As soon as you get back to your plugins, we can start adding them to the registry as well. The only thing you have to provide is this JSON file and some additional information. We can query most of the information that's given with the plugin. So in the future, a user will actually be able to, without downloading a plugin, find out information like which calculations and parsers does it provide. Does it provide any command line commands or even GUI applications? Where can I download it from, and so on.